Hi dear students, welcome back to my session. In our previous session we discussed a few problems. Again, the problems are related to your laws, rules and techniques. In this session also we will see some few more problems which are related to again DC circuits. It will take a few more sessions for the completing of the variety of problems on the all the basic laws of electric circuits. After completion of few more sessions, we will move to the next chapter, that is a DC theorems, or I can name it as a network theorems. So before moving to the network theorems, it will take us to at least two to three sessions to finish the various types of problems. After that, we will move to the next chapter, but don't worry about that one. We will finish the all the concepts. Don't hurry on the electric circuits because this is a very important subject for your semester and your next linked subjects also. So you guys need to be concentrate this subject very well. So that's what I want from your side. So let's begin the session today's. Again, problems some complicated circuits. Here we are going to be solve some little bit complicated circuits. On yesterday's session we also solved one complicated circuit, like we added the current source on the circuit, then we removed by adding the current source element, the value of current source in the particular branch, then we removed that current source on that session. So that is also comes under the category of complicated circuits. So let's see. As we know already, we have some set of rules. Here also I am going to be represent for the small rules. Just remember, this is not an important to make a note of it. Just remember from your side. The net voltage change around any loop is zero, as you know already. That is called the energy conversion. Means KVL. Already I said KVL is nothing but a energy conversion. KCL is nothing but a charge conversion. The net current into any junction is zero. That is only said. Let me add my marker. Right. This means energy conversion is nothing but a KVL. Charge conversion is nothing but a KCL. Same. The definition of KCL: the current entering at a node is equal to current leaving from that node, and the closed loop of any circuit, the voltage drop and the summation of voltage drops and the summation of EMF should be equal to zero. That is the definition of KVL, as already you know. You can frame in this way also. The net voltage change around any loop is zero. Same, the net current into any junction is zero. That comes under the KCL. Using these two rules, we can always get enough equations to solve for the currents if we are given EMFs and resistance. What I'm trying to say, if you know these two set of rules, whatever if you apply the mesh analysis, nodal analysis, see, and if you apply the loop equation based on the branch currents, loop equation based on the loop currents, so all whatever you are writing the equations based on the all the laws, all the rules, the finally those rules are merged with this KCL and KVL only. But what I want to say, so these two are fundamental rules. Based on these two rules only, all the equations are going to be solved for the finding of currents. If we have the EMFs and resistance values are there, then only we can use these rules. So let me solve small little bit problems. Here there are two batteries, E1 and E2. Here I have two batteries, E1 and E2. E1 is at 24 volts. This is E1. E1 is 24 volts. E2 is 12 volts. And my R1 is 5 ohms. Let me write R1 is 5 ohms. R2 is 30 ohms. And R2 is 30 ohms. R3 also 30 ohms. E1 how much? 24. E2 12. now he wants to know the find all currents, means I1, I2, I3. The examiner want to know the current in each branch. That what can say in theoretical way, in description way, currents in all the branches, I1, I2, and I3. How we can find the current in all the branches? You can follow any one of the methods as you know. So here for the finding of that, I'm going to follow the KVL. Sorry, I'm going to be write the loop equation based on the loop currents, or you can write the loop equation based on the branch currents. Let's see what method I follow. So example, I can write it left hand loop. That is nothing but this one. This is left hand loop. This is right hand loop. So for this problem, I wrote like this: I1, this one, and for this, instead of writing like this, I can write directly like this. That is one of the method, but our fundamental method is you need to be active any one of the source. Let me write the loop equation. Here I have two loops. This is one loop 1, this is loop 2. Now you need to be assume current of this 2. I'm going to be activating of this 24 volts. I'm not going to be considering this. So hence I'm going to be give the indication of plus minus based on this current. If I take the currents of this I3, instead of I3 I'm going to be take I1. This is I1 of current. I1 is going to be split like this, 1 and 2. If this is I2, and my current direction of this next direction is, this is I1 minus I2, right? So these are the your assumption branch currents based on our rules, not for this slide. I took it this slide from some other site. So that is the reason he given one of the methods. So I want you guys go through these methods. This method give the same answer, our rule basis methods. So here I'm following our rules, I1 minus I2, then you will get the value of, right here, the branch current name is this one, is this not I1, this value is I2. I1 value will be not that I1 is I2, I2 is I1 minus I2, I3 is I1. So this is your assumption, right? Now write the loop equation. How you can write the loop equation? I am following the loop equation based on the loop currents, sorry, branch currents. From here I can I used to follow the leaving sign minus 24, sorry, plus 24. My leaving sign is plus 24. Then my leaving sign of voltage drop here minus 30 into I1. Next, here the leaving sign is minus 5, plus and minus, right? Plus and minus. My leaving sign is minus 5. I1 is nothing but I2, right? So I2 is equals to 0. Hence, the value will be 30 I1 plus 5 I2 is equals to 24. So this is equation number 1. Next, what about the equation number 2? Equation number 2, I used to start from the independent branch. From here or here, you can use 30 ohms or you can use 12 volts. The living sign, let me start from the living sign. The living sign of this battery is minus 12, minus 12, minus 12. Next, the living sign is plus 5 into I2. Next, the living sign is minus. Here, this is current plus and minus. The living sign is minus 30 I1 minus I2 is equals to 0. If I solve this equation, minus 12. If I solve this equation, then what I get? Minus 12. Let me write that equation one moment. So we are here minus 12. Let me write that equation again. Minus 12 plus 5 I2 minus 30 I1 plus 30 I2 is equals to 0. Minus 30 I1 comes here. 30 plus 5, 35 I2 minus 12 is equals to 0. Then 30 I1 minus 35 I2 is equals to minus 2. So that is equation number 2. Let me write that equation also. Equation will be 30 I1 minus 30 I1. Let me write clearly minus 30 I1. Let me do erasing this. So here minus 30 I1 plus minus 30 I1 plus 35 I2 is equals to 12. This is equation number 2. If I solve this equation 1 and 2, because here the plus 30 I1, here minus 30 I1, both are get cancelled, then I can get 35 plus 5, 40, 40 I2 is equals to 24 plus 12 is nothing but 46. So 36. Then I can get the value of I2. I2 is nothing but a, if I solve these two equations, I will get I2. Otherwise, you can use this calci. I can get the I2 is nothing but a 24 plus 12 is 36 divided by 40. My I2 will be 0.9. Instead of you can find the I2, you can use directly equation format mode equation unknowns 2. If I type these equations in your calci, you will get directly I1 and I2 unknown values 30 and 5 equals to 24. Then minus 30 plus 35 equals to 12. Then my I1 value will be 0.65. Let me write this equation here. I1 is equals to 0.65 and I2 will be how much? 0.9. So these are the 0.9 amps. So these are the currents. So these are the currents. Then I need to be insert this I1 and I2 here, then I will get all the branch currents. Let me use other pencil color. right? Here you got the I1 and you got the I2. Now what about the I1 minus I2? I2 is nothing but a, wait, this is I1 minus I2. How much value? I2 value how much? 0.9 amps, right? Next, what about the I1? 0.65 amps, correct? 0.65 amps. What about the I1 minus I2? How much value of I1 minus I2? I1 minus I2 is nothing but I2, right? I1 minus I2 here, it means I1 much 0.65 minus 0.9. 0.65 minus 0.9 is nothing but a minus 0.65 minus 0.9 is nothing but a minus 0.25. Then the answer will be minus 0.25 as per your direction. If you want to know the exact I2 directions, means here the I2 direction is like this, right? Then it will become a plus 0.25. Hence, my currents of this particular branch are, let me write all the currents based on this. I1 is how much? 0.9. The value of I1 is 0.9. Then value of I2 is, where is I2? From here I2 is nothing but I1 minus, then 0.25 plus 0.25. Correct. Next, what about the I3? I3 is nothing but your I1. How much value of I1 is nothing but a I3 is nothing but a I1 0.65. 0.65. So these are the currents you got based on your rules. Let me check. In this PPT, there is a different method is there. Some textbooks they used to prefer that method also. But based on your method, you got the answers. Let me check your answers is correct or not. 0.9. He followed the one different way of analysis. See here, I1 how much? 250, right? 250 milliamps. I3 650 milliamps. I1 900 milliamps. Same is instead of writing 0.9 amps, he followed the 900 milliamps. Instead of writing 0.65 amps, he converted 650 milliamps. Instead of writing 0.25 milliamps, he is converted into the 0. Instead of writing 0.25 amps, he is converted to the milliamps. That's it. He is getting the three in terms of three numerical times. He is getting in 100 times in terms of 100 time he's getting the answers. But if you writing instead of writing milliamps, if you write directly amps, it will get in 0.9 0.65 amps, you will get the answers. But you need not to worry about the is it required to mention the currents in milli. It's not required. You can mention in amps. That's it. You will get a marks. Don't worry, whatever you are following the procedure is correct. Some textbooks may used to give this procedure. Please go through this procedure. If you comfortable on this procedure also, you can go through this method. But as per my analysis, as per my perfectionist on the circuits, this method is better for you guys, because this method will give the lot of complications and lot of the contradictions. You will get a confused while you're solving the problem. Instead of going to different analysis, you guys need to follow this method. Only we wrote the two steps, right? One step this, one step this two steps. We solved these two steps on the calci. Directly we got these answers, three. But here we need to be go for the junction again. We need to be write the loops. So again, there is some little bit complication. Same in the types he is writing. He is writing 25 and 35 amps. Same equations he received also. So same principle he is following. Don't confuse, right? And look like both methods are same, right? If you follow, Here you got the 30I1 5I2 24, right? Here also 30I1 5I2 24. Some 30I1 5I2 something. Same types of answer you get. So this is the method for finding of currents in all branches. Hope it clear. Let me move to the next slide. Check by using other loops. Let me check E1, E2, E3. So if you substituting the values of the your 0.65 and 0.25, you need to be get 0 amps. So you will get 0 outside. Then only that will give the KVL loop, right? So if I follow the 24 like this, 24, 30 minus 12 like this, if I follow, you will get 0 value. Means outer loop like this. This is the outer loop, right? Like this. You can follow two different loops. In the outer loop, you will get 0 value. Outer terminal you will get means 24 minus 30 minus of minus means plus 30 into this voltage drop, and this batteries. If you add this all, you will get zeros. So repeat with difference of R1. If I change the R1, means exercise for the student. Same equations give negative I2 in this case. This means current going downward through right hand battery. Right? Try to do at your side. This is your exercise. After changing the current, sorry, after changing the value of R1, in our previous slide, here the R1 value is 5 ohms. Instead of R1 value 5 ohms, I am giving 40 amps, 40 ohms. Then try from your end. Then you will get in different directions of current. Then start analyzing of the currents. Then redraw the final circuit by adding the currents. Hope you clear. Right. Let me move to the next slide. Example that don't involve so much algebra but focus on the ideas of current and voltage. What I want to say, I already said many times here. I never concentrate on the algebra. I always focus on the writing of the equations, ideas of current and voltage. I want always focus on your ideas, how you are writing the equation, which method you are using for the writing of equation, how you are finding the branch currents. Your ideas are important here. The mathematical part is not important. You can solve by using any types of ways. You can use a scientific calculator by finding out of those currents, and you can use matrix form by finding out those currents. There are a lot of methods, but the equation of writing of equation, you should follow the electric circuits method only. That's it. So even though you have the multiple circuits, so you need to write down the equation from the loop rule and the junction rule. Means here the loop rule is nothing but a mesh. The junction rule is nothing but a nodal. You may not have the actually solve simultaneous equations. So while you're writing the loop rule means mesh analysis or loop equation based on the loop currents method or mesh analysis method comes under the same category. Or you can follow the junction rule means is nothing but a junction is nothing but a node, right? Node is nothing but a KCL. KCL is nothing but a nodal analysis method. While you're following the nodal analysis also, it will come under the junction rule category. So you may not have the actually solve simultaneous equations. So there are very less equations for the solving of those types of techniques, right? Simply examples. Both these problems can be solved for one unknown at a time without messy algebra. So how you can do that? Let me see. Here, this is a battery plus and minus, and this is the battery. Just look at this problem carefully. Plus and minus. Here you want to know the current, right? I1, I2, and I3. You can use loops. Then you can find the currents, right? Giving sign plus I2. if you look at the circuit carefully, you will this is very important circuit, and you can learn a lot of things, a lot of different ways of techniques you can learn by using this circuit. Please try to focus here carefully. Let me use this here. For the solving this types of circuit, you need to be follow the simple way of technique. No need to be redraw this current paths again. In the question he gives, in the question itself, he given the clear directions. This is I1 direction. Let me add my marker. Right. In the question itself, this is a question. In the question itself, he given the clear. In this question, he want to know the currents I1, I2, and I3. Right. He wants to know the current based on the direction only. No need to be change the current directions. You should not change the directions. If he given the question like this, you should follow the same direction of currents. You should not change the directions. So I'm not going to be write the again the changing of the currents of plus and minus. I used to follow the same currents I1, I2, and I3. I'm not going to be changing any currents. Here I have the two loops. Or you can follow this different ways of currents. Means first you should know this is a positive and negative. Already you know this is negative, this is positive, right? For the finding of the currents, these three unknown values of currents means I1, I2, and I3. You should follow the loop equation based on the branch currents. For the here the branch currents already he given I1, I2, and I3. Here this is the branch currents I1, I2, and I3. For this I1, you know this is the currents flowing from this side. Already he given the direction. Then the signs are this is plus and this is minus. For the flowing of this currents, the signs is this plus and minus. So already this current is given this direction I3. So now you need to be write the loop equation for this. So let me write the loop equation from here. Right. Let me show you again. This is plus and minus. This is minus. This is plus. Already we indicated those values, right? So let me write here itself only. That is better for us. But if I again the using of sign, that is waste of time. From here, I can follow the two different loops. I can follow this loop, or I can follow this loop, right? For the following of this loop, or I can follow this third loop also. But you need to follow only two loops. Let me draw this circuit only. I'm finding this current. Already this is the I2 value of current. This is I2. Already he given in question itself only. This is I2. This is plus and minus based on the current direction I given. This is 18. And this is the value of minus and plus. This value is 9 volts. Now this is I3. Don't involve this I3. This is I3. That is not important here. Now you need to be use clockwise direction for the writing of loop equation for this. Right. Now I am writing the loop equation for this particular loop only. This downside of this circuit. For this, the leading sign is minus 19 minus 9, and for this leading sign is minus 18. Drop means I2 is equals to 0. Then my I2 value will be minus 9 by 18. Then my I2 value will be I2 is equals to 0.5 minus 0.5 amps. Hope it clear. What I am trying to finding here is I2. Now I got the value of I2 is nothing but a minus 0.9 minus 0.5 amps based on the same direction in the question itself. Either may be correct or wrong, your answer is going to be decided. But in the examiner, he wants to know the I2 in the same direction. You need not to be change the direction again. So in the question itself, he given the left side, left to right means you need to be given the same direction of current, that is 0.5 amps. Now let me find the other current of this I1. For the finding of I1, you have the two currents, right? You can use this branch. Let me write this: A, B, C, D, E, F. Now this is nothing but F, C, D, E, F. This is F, C, D, E, F. This is F, C, D, E, F branch, and this is A. Now you can, for the finding of this I1, you can use A, B, C, F, A branch, either A, B, C, F, A loop, or you can use A, B, D, E, A loop also. So already you know the method of finding of middle branch. If you take common, how the method is going to be solved by using of this middle branch. Already you know that procedure. Let me do in a different way. Let me write this A, B, D, E, A loop. Now I am going to be draw this on that loop. Right. I'm going to be drawing that loop. How that loop look likes. Wait one moment. Where to write? Let me draw here. Let me draw here. This is this place. Minus plus. So this is the 5 ohms, and this is wait. This is 5 ohms. What about this? This is a 9 volts. What about this? 3 volts. And right, this is the direction of current from here. This is the current direction I1, right? Then based on the current direction, the signs are going to be decided, plus and minus. Right. Now you need to be indicate the loops. I'm using different color. Right. This is the loop, always clockwise. Now let me write the loop equation for this. A, B, D, and E. I'm writing the loop equation for A, B, D, E, A loop. Let me write this. Why I used this 9 volts means 9 volts is larger battery size. That is the reason for the finding of 18 amps. For the finding of current through this 18 amps, I used the reference of 9 volts. For the finding of I1, I used it with the reference of 9 volts. That is the reason I am going to be drawing. I drawn two different loops with the reference of 9 volts only. Hope you understand why I included the 9 volts in two loops. Or you can follow the for the writing of this 18 amps, you can follow this particular loop. Otherwise, it will give some little bit complication of the lengthy equation you will get. That is the reason I followed this outermost loop for this circuit. So I am writing the loop equation. Let me start from here. My leaving sign is -9, leaving sign -3, and for this current plus 5, the voltage drop is plus 5 I1 is equals to 0. Hence I1 is equals to 9 plus 9 plus 3 is nothing but a, sorry, that is I1, right? This is I1. I1 is nothing but a 12 by 5. Sorry, 5 by 12. 5 by 12. Then you will get how much? 5 by 12 is nothing but a 0.416. I1 is 0.416 amps of current which is flowing. 416 amps of current which is flowing through that. This is I1. You got it. Hope let's see our slide. Right. I1 is nothing but a not 12 by 5. Not 5 by 6. It should be 12 by 5, right? Not 5 by 2. Let me remove this screen. Options eraser. Which is 12 by 5, not 5 by 12, because 9 by 3, right? 12 by 5 only. Find options. 2.4. The answer is this is 12 by 5. Then my I1 will be 2.4. 2.4 amps. I2 will be minus 0.5 amps. Now you know the I1 2.4 and you know the I2 minus 0.5. Then you know the I3, right? 2.5 minus 0.5, then the rest of the value will be minus into minus plus, right? Plus, then this is will be delivery value. It should be 2.9. My answer will be 2.9. How that will comes? Here already you know the value of I1 is nothing but like this direction, right? I1, how much value? 2.4. Here based on this direction, this is I2, right? I2 means 0.5. I2 is 0.5 minus 0.5. If I reverse of this direction instead of this side, if I make reverse, it will become a plus 0.5. So then if I take A, B, C, D, E, F, for this F, A, B, C, D, A, B, C, D, E, F, for this F point, there are 2 points, two different currents are entering. One is 2.4 currents, one is 0.5 amps current. Then the I3 value will be how much? I3 is nothing but a 2.4 plus 0.5. Then the I3 value will be 2.9 amps. So this is the way of procedure to find the currents in particular branch. This is one different methods you can follow. Instead of the writing of branch currents as per your thoughts, you can follow the as per the problem given. If in the problem is given based on the directions, you can follow those directions instead of your directions. Your assumption of directions instead of your assumption of directions is um, not required. Sometimes you can follow directly, sometimes you can follow the directions of current directly is given on the problem. So that's what I want to conclude in this problem. You can there is a no rule. The assumption of current is mandatory. You can follow the any direction of current, but the direction of the current particular is very important of the signs. Whether the current is left to right or right to left, the signs are going to be decided. Based on the signs, your loop equation is going to be decided. Based on the loop equations, then the current flowing through the particular branch is going to be decided. So here the direction of current is not a mandatory, the signs indication is mandatory. What I want to conclude by using this problem. So here you can check your answer is correct or wrong. So how you can going to be checked? Don't bother about this. Here he followed living sense. Sometimes I used to follow the living sense. Sometimes I follow the starting sense. But I given the rules based on the living sign only. Don't confuse about this equation. But your answers is getting same, minus 0.5 plus 2.4 plus 2.5. Your answers is getting same results. So here let me check. Here let me check. And it is. So here, let me check your answers are correct or wrong. How you are going to be checked? Means here P input. Input power is nothing but how many sources for this input? There are two sources. One is 9 volts battery, one is 3 volts battery. For the finding of power of this 9 volts, you require current, right? So what about this current? What about this current of what about this power of this battery is nothing but a 9 volts into I3, right? Plus what about this second input? 3 volts into I1. So there are two powers, two inlets, two inputs of this loads. How many loads? 5 ohms and 18 ohms. Hope you understand what I'm trying to say. I'm trying to say I want to adding of input power. Then is that input power is supplying to the output output loads are correct, or loads are not. Then I am going to be finding based on my power checking analysis. This is called power checking analysis. Here, the input power is nothing but a, what is the power formula? V into I. Am I correct? Or sometimes I square R. Or sometimes V square R. Based on the given parameters is given on the problem, you can follow the any one of the equation. But what I want to say particularly, if the circuit is on load, if there is any load RLC like that loads are given, you should always follow the I square R for the output measurement of output power. If circuit is given on supply side, you should follow the input power like V into I. Again I will repeat it. If the finding of power at load, you should follow the I square R. Means there is a dissipation of heat is happening. It is the dissipation of heat is happening means as per the Joule's analysis, H is equals to I square RT. Based on that analysis, the heat is dissipation happening. So for the heat dissipation, the current will plays in major role. That is the reason instead of following the V into I, you should follow I square R principle. So for the finding of for the measuring of power across any load, you should follow I square R. For the measuring of power across any battery, you should follow V into I. Hope you clear. So here, that is the reason I am following V into I plus V into I. Here I am following I square R plus I square R. So right, hope you clear. Now let me find the power input. Power input is nothing but a voltage into current. How much value of current I3? As you know, I3 how much? 2.9. If I do 9 into 2.9 plus 3 into what is the value of this battery? 3 into my current. How much value of I1 current? 2.4. Then I will get 33.33. This is input power. Is that input power equal to the output power? Whatever the input is supposed to be output, then only your answers are correct. Then my output power, where my power is going to go, where my power is going to be consuming from battery, sorry, from load. Here what are the load elements? 5 ohms and 18 ohms. For the finding of power at 5 ohms, what is the formula? P 5 ohms is equals to I square R. Means current flowing through this 5 ohms square into resistance of that 5 ohms. Then current flowing that 5 ohms is nothing but a, how much current is flowing for the 5 ohms? 2.4 whole square into resistance of that 5 ohms is nothing but a 5 ohms. This is P5. What about this other power at what about this other element, other load element 18? For the finding of power for the consumable of power at 18 ohms also same analysis. P18 is equals to I18 square, current flowing through this 18 ohms into resistance of that 18 ohms. Then I18 is nothing but a I2. How much I2? I2 value will be 0.5 minus 0.5 whole square is nothing but a same value of will comes to the picture 0.25 into my resistance 18. Then you will get same value 33.33. If your calculus, please do check from your side. So this is way of checking of the problem. The input power is going to be consumable in output. So that's it. So for this is one of the different way of approaching. Hope you understand what I'm trying to say. So there is no proper way of finding of currents. Is that the naming of branch is not a mandatory. You can follow the representative value already given on the problem. You can follow those current directions. But here the sign indication is very important, and the assumption of your loop either maybe clockwise or anti-clockwise. That is the important for the writing of these types of equations. Right. Hope you clear today all the topics. Thanks for your time. We will meet again. Thank you. Bye bye. Have a good day.